So, hallo Leute, erstmal schönen guten Tag. Ich führe euch jetzt hier vor einen Ausschnitt aus einer Live-Sendung. Die haben der Foster Gamble und seine Frau Kimberly gemacht, zusammen mit einem Greg Braden, den ich nicht näher kenne. Ihr wisst, ich wollte doch da ein Referat machen zum Menschen als Biomaschine. Da fehlte mir noch irgendein Kick und ich glaube, nicht als brauchbaren Denkanstoß, sondern sagen wir mal als kleine Einfügung, habe ich hier Gedanken gefunden, die hinzielen auf eine ganz andere Form von Wissenschaft, die wir noch nicht haben und sagen wir mal physikalischen Funktionen im gesamten Weltraum, die wir überhaupt noch gar nicht kennen, die aber für uns als Menschen auch maßgebend sind. Guckt euch das hier einmal an. Ja, ich will hoffen, dass ihr davon etwas mitnehmen könnt und dann werde ich mal langsam mich daran machen, meinen Vortrag zu halten. So, bis dahin, tschüss, ne? Und denkt an die Kinder. Verdammt nochmal.
And the ultimate battle is nothing less than the battle for our very humanness. Our very humanness is at stake. Our very humanness is on the line. And there is a thinking in parts of the scientific community. It's not all scientists, but I am surprised at how prevalent this and how well accepted this thinking really is, that we are in essence carbon-based life in general, and humans specifically are a flawed, inadequate species, but that's okay because we're going to fix it with machines, AI, chemicals, nanoparticles, and this is happening. It's no longer theory. It's actually implemented in some societies. It's being accepted very quickly, and we're not talking about it in the US. The old story is just that we are weak, flawed, and inferior, that we need something outside of us to save us. That's the old story. I'm going to share the new story, the discovery number one. I'm speaking directly to our community here. I want to offer you a very empowering way of thinking of yourself that you probably will not see supported in your kids' classrooms or your textbooks. But this is supported in rock solid peer-reviewed science. So the average adult, whatever that is, we're all average, I guess. We've got about 50 trillion cells in our body, give or take, some more, some less. Here's the point. Every cell, no matter how many there are, has an electrical potential. It's a small one, about 0.07 volts. And you say, well, that's not very much. And I say, you're right, but look at this. You do the math, 0.07 volts times 50 trillion cells, we're talking about 3.5 trillion volts of electrical potential. Now, I know I've seen this in the conference. People take notes, they write this down, 3.5 trillion, because we can't really even wrap our minds around what that is. So I want you to just get a sense of this. This is a 12-volt battery. Usually you see it in your automobile. This happens to be from our solar panels. It's a solar energy is stored in these batteries. That's a 12-volt battery. It takes 3 billion of these to equal the potential in one human of electricity. 3 billion 12-volt batteries equals one human electrical potential. Now, wow. Why don't you think about that? What do we do with that potential? But it doesn't end there, because every cell in our body functions as a transistor and as a resistor. They used to look like this in the old technology. Now, capacitors. Each cell in the body functions as a capacitor. Now they look like this. But they still mimic what our cells already do. Every cell is a resistor, it's a transistor, it's a capacitor. Every cell in our bodies emits photons of light, and we receive photons of light. That's information. We are storing and receiving and generating and transmitting information as light that can be measured. Every cell in our body, on the exterior of the cell, there are transmitters and receivers. We call them receptors. Chemical signals as well as electrical and subtle energetic signals are coming to us, and we transmit those. It doesn't stop at the cell membrane. The level of our DNA, the strands of the DNA and the genes that make up the DNA essentially function as antenna for subtle forms of energy. We transmit, we receive this energy. Every cell in your body stores and retrieves information just like that computer chip you see on the screen, and so much more. So what I'm saying to you is that the technology that we built in the world around us, as advanced and sophisticated as it is, the essence of every function in the outer technology, it mimics what we already do in our biology. It mimics, and this is a very different way of thinking about this, rather than hard chips and wires and chemicals, we are neurons, cell membranes, crystalline bone, and ion potentials moving across cell walls. That is a very sophisticated technology. We literally are a soft technology. We are the technology that we've been waiting for. We are the technology that we're trying to build in the world around us, except our bodies do all of those functions better than the technology can. And we are scalable. We can go from different levels of application that the AI and the chips are not able to do. So this is important because all of a sudden, rather than being vulnerable and somehow being inadequate, defective forms of life, we are highly advanced, highly sophisticated, technological forms of life. To build all of this into tissue and bone, it's easy to build it into a chip or a wire, but to build it into something that can regenerate and rejuvenate and become more through its lifetime. Wow, what a powerful technology. And here's the key, we regulate all of that power. Not only do we regulate it, we self-regulate it through thoughts, feelings, emotions, beliefs, focus, breath. And this is the essence of our most ancient and cherished spiritual and indigenous traditions. This is what they're saying to us in a non-scientific language. And this is why I think these traditions have been so cherished in the past. So the question is, okay, soft technology, highly advanced, where does it come from? Where does it come from? And the answer to that question is rocking the world of science. So one of the things, and we could go on and on, I just pulled a couple of ideas to launch our conversation.
Love it.
We now have the ability to extract the DNA from the fossilized remains of the beings that we used to believe we descended from. We can pull it out of their fossilized bone marrow, and that means we can compare their DNA to ours. Now, I put a little image on the screen. That's actually fossilized DNA that you're seeing right there coming out of the bone marrow. So this isn't a metaphor. It's not make-believe. I mean, it's a real deal. What it is telling us is that we did not descend from the forms of life that I was taught when I was in school, and we're still teaching our kids today, even though the evidence doesn't support it. We didn't descend from Neanderthal. We shared the earth with them. We didn't descend from them. We may have Neanderthal DNA because we interbred. They say we had Neanderthal boyfriends and girlfriends. So some people say they still do, but that's a whole different story. That's a different workshop. But the point of this is that anatomically modern humans, that's what we're called. Scientists are in total agreement of when it appeared on Earth. And they say we showed up mysteriously about 200,000 years ago. Here's the kicker. We showed up fully enabled, fully intact, with all of the potentials and the capabilities that we have now already with us. The extended neural network, the brain capacity, over 50% larger than any of our primate relatives. The ability to self-regulate, all of those were already with us. They did not develop slowly, gradually, over long periods of time, and they have not changed. When we look at our DNA today, that's what the scientific journals are saying. When we look at our DNA and we compare it to the DNA of the early forms of us, it's the same. We haven't changed. Now, just to be clear, I'm a geologist. I believe in evolution. I've seen it in the fossil record for many forms of life. Plants, animals, insects, it breaks down when it comes to humans. Something happened 200,000 years ago, and that something is a series of mutations. And it's not just one. Human chromosome 2 I'm going to talk about because it's one of the most profound. Human chromosome 7 that gives us the ability of complex speech and allows us to sing in a way that You'll never see a chimpanzee sing Stairway to Heaven. Okay, as a musician, that was my big question. If we share 98% of their DNA, why aren't they singing in the trees? And they don't, because there was a shift in our chromosome 7 200,000 years ago that connected our tongue and our mouth and our brain and gives us the ability for singing in complex language. Human chromosome number 2 is perhaps one of the most mysterious, and it may be the smoking gun to answer the question, where do we come from? Now, chromosome number 2, it's the second largest chromosome in the human body. And I want you to know it's responsible. I don't want to get into a lot of the details, but it's responsible for our uniquely human capabilities, things like emotion, sympathy, empathy, compassion, the ability to self-regulate our biology are all made possible because of chromosome number 2. So scientists say this is a pretty important chromosome. Where did it come from? This is a very technical article. It's from Proceedings, National Academy of Sciences. The volume is called Genetics. The bottom line, I won't read this, but the bottom line is that scientists agree that human chromosome 2, and I'm showing you your chromosome 2 on the screen right now, it is the product of a fusion of 2 pre-existing chromosomes that were fully intact, fused together, and you can see there's the little pinch point right there where they were fused. And it's not that they were fused, but even more than that, after the fusion happened, genes were added, genes were taken away, functionality was tweaked to optimize and stabilize what it is that gives us our humanness. And you say, well, that's unusual, but, maybe it's a fluke, it could have happened. If it were only one chromosome, I would say maybe. It's not. The fact that chromosome 7 and others, and they all happened at the same time, 200,000 years ago. They did not happen slowly, gradually, over a long period of time, and they haven't changed. So what science, and if that looked too technical, I've got a little movie here, literally 2 chromosomes coming together and genes being added, genes being taken away, and this fusion that's happening. The timing, the fact that it happened when we emerged on this earth, the precision of the adding and the taking away and the fusion and the splicing, and the end result. The end result is us. Scientists are in agreement that something beyond evolution is responsible for this. And this is the showstopper, because it suggests an intentionality, and underlying an intentionality, it implies a purpose. And our scientists today are having a hard time coming to terms with a biology that resulted from any kind of an intention or a purpose. So the reason this is important, we appeared 200,000 years ago, we've got these extraordinary capabilities, and now they're not recognized, they're not embraced. And there is a movement to replace our natural biology with technology, with computer chips in the brain that communicate with the hard drives of our computers, with alternate chemicals in the blood that redefine what a human blood type is all about, with wires under our skin, with nanoparticles. There is a movement to replace our natural biology. And let me share with you, and I'm not against technology. I worked in the Star Wars Defense Initiative during the Cold War. I've seen lasers, radar systems. I am not anti-tech. Here, this is the essence of our conversation, Kimberly. When we replace our unique biology with machines and AI and tech, our natural abilities begin to atrophy. Our neural connections begin to decouple, and we begin to, cells cease to function. Fertility rates drop. We're seeing this happening in Japan right now. Digital intimacy is having a direct impact on the birth rate in the Japanese culture, and they know this. Women are less fertile, sperm counts are dropping in men. The birth rate now is lower than the mortality rate. They're dying faster than they're making babies. It's not 100% because of this. This is a big contributor to it. When, we've all heard this, use it or lose it. If we begin to replace mirror neurons with computer chips in our neocortex, for example, or begin to replace these subtle functions. I mean, think about this. We communicate with subtle energies and subtle forms of life. by tuning our nervous system, scaling our perceptions to these subtle forms of energy. When we begin to replace our natural biology with technology, we begin to lose that. Okay, it happens in one generation, maybe for fun, maybe for recreation. Maybe young people say, hey, I want a chip in my brain so I can do my gaming without using a keyboard. And that's possible now. But here's the implication. The next generation, our body says, oh, we no longer need that function. And we begin to erode and lose the very capabilities that give us our humanness. And my question is, how much of ourselves are we going to give away to the technology? We cannot answer that until we know who we are. And we're only beginning to understand what it means to be human. So my work, where my passion is right now, the implementation and the acceptance, the technology is happening faster than the morality of how it's applied. And we're at this crossroad right now. This generation, it's not going to take long. This generation must determine what are the human values that we cherish in our species, that we choose to make the foundation around the choices of technology. Because if we don't make that decision and we don't identify those values very quickly, they will be lost. And once they are lost in a species, they are lost forever. And that is the power of this conversation. That's why I'm so appreciative of you inviting me here to talk about it. Transhumanism, you talked about the three phases, the augmented biology, a titanium hip, contact lenses. We all do that. There's nothing wrong with it. The second level is where the thinking is that the body is so flawed that we must replace the body. We keep the brain, but we replace the body, and either replace the body robotically or with some other form of life. The third form is really interesting, and I think it betrays the thinking underlying transhumanism, because the thinking is that we can be reduced to ones and zeros and stored, our essence, on a computer chip for immortality. And I think ultimately the transhumanists, the really hardcore transhumanists, are afraid of death. And what they have not understood is that they already possess the soft technology that gives them lifespans at least in hundreds of years, possibly immortal. It's even more advanced than they've been led to believe because it is a soft technology. We are the very technology that they're trying to implement. So wires, chips, chemicals, they mimic who we already are. And that's what I'm just going to stop right here. And I'll say, this is something I want everyone to really consider, that we are technology. We are soft technology, the very technology that we've been waiting for. The world changed. And if we're ever going to embrace the deep truth of our humanness, now is the time to do that. And I think that'll lay the foundation for our conversation, Kimberly.
Oh,